Okay, so in this video I'm just going to show you the binomial theorem, and the binomial theorem technically states that how we can basically expand this where n it's some natural number or some integer that's not negative. And then you can basically represent this as the summation from k equals 0 to k equals n, and then you rewrite this as n combination k multiplied by a to the power n minus k multiplied by b to the power of k. This is the binomial theorem, and let me just show you how it works. Let's say, for example, you want to find x plus y squared. If you want to find the expansion of x plus y squared, this basically means this is the summation from k equals 0 to k equals 2 of 2 combination k multiplied by now a. This variable here will just be for a now, so you'll replace a with x. Then you have x to the power 2 minus k multiplied by now this one's our b will be y now, so it will be y to the power of k. So now the first thing you'll do is substitute in k equals 0 everywhere here. So you're going to have 2 combination 0, and x to the power 2 minus 0 is 2, y to the power 0 is just 1, plus, since it's the summation of that, now you plug in k equals 1, so this will be 2 combination 1 multiplied by x to the power 2 minus 1, which will just be x to the power of 1, multiplied by y to the power of 1, which will just be y, and then plus, now the last one you substitute is in k equals 2, so you have 2 combination 2, x to the power 2 minus 2, that will basically be 1, and then you have y to the power of 2. Okay, so now 2 combination 0, that's 1. Yeah, I'm pretty much sure you're familiar with the combinations. How do they work? A combination, okay, let me just show you. N combination r, that's just gonna be n factorial over r factorial into n minus r factorial. So now when I say this one, 2 combination 0, so this will just basically be 2 factorial over 0 factorial over 2 minus 0 factorial, which will just be 2 factorial again. Then the 2 factorial and 2 factorial will cancel out. Then just basically have 1 over 0 factorial, and 0 factorial is just 1. 1 over 1, that's 1. So here you'll just have 1. 1 multiplied by 1 is 1 multiplied by x squared, you'll just have x squared. Repeat the same process for this one, then you'll get that 2 combination 1 is just going to be 2. And then 2 combination 2, you can do this process and you'll check, that's going to be 1. So you're just going to have y squared like that. So that's how you'll expand using the binomial theorem there. But now this is basically not about expansions only. Let's say we want to find coefficients as well. Let's say maybe we have 3x minus 6 over x, and we want to find the coefficient of let's say here we have 7, and we want to find the coefficient of x cubed. Let's say here's something like this, and they ask you to find the coefficient of x cubed. This is basically where the theorem comes in handy now. Okay, let us simplify first. So we're going to have this rewritten as 3x minus, but I'm just going to denote that with a positive, and I say minus 6 x to the power minus 1, something like this. So now this is your new a, and this inside the inner brackets, that one is just going to be your b. Then rewrite this in the binomial theorem form. Then we're just going to have from k equals 0 to k equals n, which is 7. And then we're going to have 7 combination k, and then you have 3x to the power of 7 minus k multiplied by minus 6 x to the power minus 1 to the power of k. But now notice that we have x and x. We need to group these x's together. So what we're going to do is like, first of all, we need the x itself. Here it just says the coefficient of x cubed, meaning that we must separate these constants from x. So how do we do it? How do we do that? It's going to use some exponential laws. Then we're going to have this being 3 to the power 7 minus k multiplied by x to the power 7 minus k. And here we're going to have minus 6 to the power of k, and then you're going to have x to the power minus 1 to the power of k. So further proceeding, you get k equals 0 to 7, 7 combination k, 7 combination k, then 3 to the power 7 minus k multiplied by minus 6 to the power of k, and then this will be x to the power minus k, and this will be x to the power 7 minus k. 7 minus k, that's just going to be the laws of exponents. You add that minus k, that's just going to be x to the power 7 minus 2k. then we have something like this. But now, what are we looking for? We're looking for the coefficients of x cubed. So that means 7 minus 2k, that's going to be equals to 3. Then take this that side and take this that side, and then 7 minus 3 equals 2k. Then we get 4. We have 2k. We divide by 2, then that means k equals 2. So this implies that the coefficient of x cubed will be equals to 7 combination, our k is 2, 7 combination 2, 3 to the power 7 minus 2, multiplied by minus 6 to the power minus 2. Oh no, so it's just 2 from this one. So let's simplify. Then we're going to have 7 factorial over 2 factorial, 5 factorial. Then we have 3 to the power 7 minus 2, which this will just basically be 3 to the 5, and minus 6 squared, that's just gonna be 36. Okay, and then let's see if we can like further simplify that. We have 7 factorial over 2 factorial, 5 factorial, 3 to the 5 into 36. Okay, so 7 factorial is the same as 7 times 6 times 7 times 6 times 5 factorial. Divide that by 2 factorial, 5 factorial. Then we have 3 to the 5, 36. 36 is the same as 2 by 18 or 4 by 9. So we can technically write 4 by 9. 4 times 9. And we have 3 to the 5. We have something like this. And then the 2 will cancel, and then you have 6 divided by 2 factorial will basically be 3. Then you have 7 times 3 times 4 times 9, which is just 3 squared, times 3 to the 5. Then simplify that to get 7. 7 times 4 is going to basically be 28, and then you have 3 to the 6. Okay, this is going to be 5 plus 2, 7 plus 3 is just going to be 3 to the 8. So that will be your coefficient of x cubed from from this one, the value from this expansion. Then the coefficient of x cubed will basically be 28 times 3 to the power of 8. So this is how you use the binomial theorem. It's technically easy, really. It's just a matter of like algebra, and it's basically simple. Just know the combinations, and this is just a summation, meaning just sum up, and then you'll be done.